Okay, now that I have set up everything on the storage, we're gonna create our purchase consumer so it can consume that information and send it to our storage layer. All right, let's do our importing. So first go ahead on services, under services, create this purchase consumer.py file. And let's do all of our imports. Pathlib, path, datetime, typing, let's import from collections, default dict, from our YAML as well. Now let's import the string deserializer. Also the Avro deserializer. And let's get our add the project root to the path. So we'll need our wrappers will be on parent 3 times. Well, also let's add the other one. All right. Project root step. Okay. Now with this, we're ready to import things from our storage layer and things also from our wrapper folder. So wrappers, consumer, Kafka consumer, wrappers, schema registry admin, storage, mini.io client, Parquet writer. So now you see that we're putting everything together. All of the wrappers, the schema registry, the consumer, and also the mini.io client and our Parquet writer. We're gonna use all of the functions we've been creating. Let's do our login stuff. So I'm gonna grab it from here, any of the scripts, and let's just name it purchase consumer. You don't actually need a name, it's just for... Okay, now we're gonna load the configurations, just like we've been doing. We need to load the config information from the YAML file that I have. All right, so I believe we have created this maybe on the event generator, so we can just copy from here. That's exactly the same function. Okay, so that's it. Now let's create a flushing logic. So the goal for this method will be, the goal for this function will be to write all of the accumulated event batches that we have to the data lake storage. So we're going to receive the event batches and we're going to send it to the data lake storage whenever they are accumulated. Okay, so let's create this. It's gonna be more clear. Flush batches, event batches, our dictionary. We also have our parquet writer, our statistics, the region. Okay, so what this method is going to do, it's going to take all of the accumulated events from the memory batches, it's going to convert them to Parquet, upload it to MiniIO with the partition structure, update the processing statistics, and then clear the batches after the writes were successful. So we're going to do all of this process that I've been doing inside this, all of the processing of the data. Okay, so let's determine what's going to be the regions we need to flush. Regions to flush is going to be the region, if the region, otherwise. Let's get all of the event batches keys. Okay, then we have our date string. We have it year, month, day. All right, so for every region in our regions to flush, we are gonna get the region from our event batches. Okay, now if the batch is empty, so if not events, we just continue. Otherwise, we're gonna attempt to write the batch, and we have the events. We have the region to be the region we're processing right now, and the date string to be the date string. Okay, so this is success case. So if we get it, let's update the statistics. So I have a batch count to be the length of events, and updates the total written batch count. And let's get a batches written to be one more. Okay, let's log that. Flushed batch count for the region events. Let's do total written stats total written. Nice. Now we're gonna clear the batch only when like we have a successful write, so which is right now. So event batches region, we clear it out. All right. Now, what we're gonna do now is create a main function, which will be the main consumer orchestration. So I just want to coordinate the entire consumer pipeline from the initialization to shutdown. All right. So it's going to load the configuration, initialize all of the components, the consumer, the serializers, the storage. It's going to set up all of the state management for all of the batch processing that we're doing. It's going to define the message processing logic, run the consumer loop, and then handle the shutdown. All right. So let's def our main function. We're going to load the configuration. Our batch size is going to be 50. So this is going to be the events per batch that we're going to process. And the batch timeout second to be 30. That's the max timeout we're going to wait before flushing. So it's just going to ensure freshness. Let's log this. Initializing components. All right. Those schema registry. Our URL is going to be from our config file. Schema registry URL. Okay. Now let's set up our consumer. It's going to be our Kafka consumer. And then the Bootstrap servers are going to be the join of the config Kafka Bootstrap servers. Group ID, purchase, ingestion, consumers, auto, offset, reset, earliest, enable auto commit, false. We want to do the manual offset management. Key, the serializer is going to be the string, the serializer, UTF-8, and the value of the serializer, the Avro, the serializer, on top of the schema admin.client. All right. Now I can subscribe a topic. Kafka topics purchases. Okay. Consumer.subscribe topic name. Now let's initialize our storage components. So the Parquet writer, and we have our mini.io client. Cool. So our event batches, we're gonna group it by region. Gonna be dict, string, list, default dict, list. The last flush time is going to be time.time in our stats. Then we can build it. Total consumed 0. Total written 0. Batches written 0. And by region from our default dict int. Okay. Now the next function we're going to do is going to be a process event. The purpose is to be able to process each individual message from Kafka. So we're going to get the key, the value, the message, and we're going to do the processing inside of it. Okay? So inside of this function, let's create this process event, key, value, message. So what it's going to do per message, it's going to check if the timeout-based flush is needed and then validate the message structure. If it's validated, we're going to add that event to the appropriate regional batch and check if the batch size limit was reached or not. If it was reached, we're going to trigger the flush if needed and then update the statistics. Then we commit the offset to Kafka. All right? So let's do this. So let's access the outer scope variable that I have defined up there. Last flush time. And we're going to check if the time-based flush is needed. So if our time minus the last flush time is greater or equal in the batch timeout in seconds, let's say batch timeout reached, flushing all batches. And then we can call the flush batches function event batches parquet writer stats. And then we say that there are last flush time. Now it's time.10. Now we need to validate and process the message. So if we get value and region, our region is going to be the value region. And then we can add to regional batch. So event batches region.append value. With that, we can then update stats, total consumed plus equal 1, and by region of that region plus equal 1. Okay, now we can check if the batch size limit was reached. So if the length of the event batch region greater or equal than the batch size, we're going to flush them as well. Event batches, parquet writer, stats, and region. All right, let's do a progress logging for us to see how we are. Okay, so if the total consumed from our stats divided by our batch size, remainder is 0, we can have like a pending to be the sum of the length b for b in each event batches.value. Then we can log that. So we can say progress consumed stats total consumed. You can say logger.info written stats total written, and then pending equals to pending. All right, finally we can commit the offset after a process. So consumer dot commit message to be message asynchronous equals to through. Now we can go ahead and build call it out the main consumer loop. So let's log this information, starting the consumer loop, press Ctrl+C to stop. And let's log as well some information, topic name, batch size to be the batch size, timeout to be the batch timeout in seconds. Then I can try to run all of the infinite messages consumption loop. So consumer.consume messages that we've created, and our process callback will be the process event. And just define over there. Okay. And finally, let's say flushing remaining batches. We call the flush batches with event batches parquet writer, and stats. And let's log the statistics. I can say total consumed. Let me stats total consumed. We can do total written, stats total written. We can do batches written to be stats batches written, and by region to be our dict of stats by region. So here it's actually a parenthesis. Cool. Let's get a storage verification. So our storage stats is going to be the parquet writer get statistics and logger.info total files storage stats total files. Oh, probably there's a typo somewhere. Info by region storage stats by region. Let me tags, yeah, right here. Okay, and then let's log that consumer close. If name main. All right, now we're able to consume everything. Let's test it out. So subscribe. It's actually a method here. Save again. Okay. So let me create the producer. We're inside services, event generator. Okay, so what's going on that we're not triggering the consumption? Let me see if have everything. Okay, so the thing was that my consumer loop is inside the process event and should be out of this, should be on the main. So take this out for the main. Okay, save it. There's also a typo here. We should have values instead of value. So let's try one more time. Okay, so now you can see that we are producing messages and writing the batches, you know, and flushing everything. 50 wrote 50 events, the size flushed 50 events. Total written, progress, reading, pending. Then flush 50, increase 50 by 50 in our batches. Okay? If you come here and check MiniIO console, now you see that I have the 3 folders and files will be increasing here. Asia, files here, EU, files here. So as we go, we're doing all of the processing, batching it, and sending to the correspondent folder by date and region automatically. And this is working just fine. With this, so it's increasing. With this, we conclude our ingestion pipeline.